Hey guys, this is Srini and you're watching Python tutorial videos on my YouTube channel Python for Microscopists. In the last tutorial, we talked about basic plotting functions that are available from within Pandas library. Again, Pandas is this library that's designed for data handling, data analysis, especially if you're doing pre-processing for machine learning or extracting information out of data and so on. So it does make sense for Pandas to make a few basic plotting functions available, but the intention of Pandas library is not plotting. So for better plotting, for better control over plotting, you may as well use Matplotlib or an amazing library called Seaborn. Seaborn, and in today's tutorial, I'm going to talk about Seaborn. It's also powered by Matplotlib in the backend, but it provides a much richer environment to work with. It actually is a great library for plotting even advanced plots with literally a line of code. So, and believe me, trust me, it really lives up to all the hype that I'm actually building up here. So let's go ahead and jump in and start learning. And before jumping in, I want to let you guys know that, if you want to know more about Seaborn, just go to Seaborn, seaborn.pydata.org. And they have excellent documentation here. You can, let's click on this to see a few of these amazing plots. They're so easy on the eye. They're very appealing. I know as scientists, researchers, we like to look at the data, but then do not underestimate the power of aesthetics. We all like to collect beautiful images, even though we know that information can be extracted from a slightly noisy image. So this is exactly what Seaborn actually provides. Easy to plot, but then they're also visually appealing. So it's a win-win right here. It's a double advantage right there. Anyway, so look at all of these, look at the documentation, and then what I'm going to cover in today's tutorial obviously is not everything, but a few common types of plots. And let's jump in. So let me go ahead and clear the screen right there from my last tutorial. And again, the data that we are going to look at, first let's go ahead and import pandas as PD, okay? And then also import the CSV file we've been working with in the since the last couple of videos, which is nothing but pd.read CSV, and the file name is manual versus auto.csv. And there you go. And what is it? What does it look like? Print df.head to look at. In fact, let's print the top 25 columns, so rows, I should say. And here you should see what it contains. The first column, well, it's not contained within this file, but it's assigned by Pandas by default, which is the index of each row. And then the second column is named unnamed 0. That's because my original file, I did not have any name right there. Okay. And this contains the set number, set 1, 2, 3, or 4. And within each set, I have 25 images. And each image has been analyzed manually for the number of cells. So a person actually counted the number of cells within each image. And these are the numbers right there. And the same image has also been analyzed automatically using the watershed segmentation that we have developed a few lectures ago. And the three of these represent three different threshold settings that segmented the cells. So, and in the middle right there, the incomplete column is person number 2 who tried to count the number of cells after the 3 cells is wise enough to quit in the middle, saying that, okay, if you have auto, that's the best way to go. I don't want to count them. Okay, but even here you can see that there's a big difference between these two individuals in terms of the number of cells, even in a single image. This is human nature, and I bet the same person, if I gave the same image one more time, that person would have ended up with a different number than 92 or 87 or 104. Okay, so within the manual column, some values are missing. And if you actually go back here and look at the index number 12, by default, Pandas assigned a value of NaN to that missing column, which missing cell, which means it's not a number. Okay, it's important to understand this because now we are going to jump into Seaborn. So let's import Seaborn as SNS and actually plot our manual column. Just look at the distribution of the number of cells from within the manual column. Okay, so how do we do that? It's just sns.distribution dist plot. Okay, right there. There are various types of plots, and go ahead and experiment with these. But I'm going to just do the manual column and single distribution plot. Okay, so I'm going to just plot these lines, use these lines, and now it actually gives me a message saying cannot convert float NaN into integer. That basically means a Seaborn is going through our manual column and looked at this unnamed, not unnamed, looked at the missing values, and it's like, I don't know what to do with that. Okay, fix it. So we have done this in our previous tutorial about handling missing data. It's nothing but, okay, in our data frame under manual column, okay, so in our data frame under manual column, fill all not numbers with what? Okay, we could have actually deleted those rows, but I'm choosing to fill them with something. I'm filling them with a value of 100 because in the previous tutorial we saw that the average value there is about 100. So why not just fill the missing values with 100, which kind of makes sense. And I'm going to say in place equals to true, which means it's going to update my data frame at this point. Otherwise, the other way to do that is df equals to this and then delete the in place equals to true, right? Either way, it's the same message. And now let me delete this from here, put it up there, and then see if it actually did anything. So our index number 12 is a value of 100, so I know that's working. So let's go ahead, and I still want to keep it just in case down here, and let's go ahead and do the plot. There you go. That's the plot that we have generated. Distribution plot, again, it's just doing a histogram plot with an overlay of something. I'm going to talk about that something in a minute, but just to summarize what we have done, we imported a CSV, the data from a CSV file, and we took care of missing data by in this example, by filling it with some value. And that's it. Imported the Seaborn library and then just used distribution plot within the Seaborn library to plot all the values in manual. Now it actually overlaid this faint looking, this another plot in there. So when you do distribution plots, it actually overlays this KDE. It stands for kernel density estimation, not distribution. Sorry, KDE. And this kernel density estimation is, I think, the easiest way to summarize that is think of it as a probability distribution function of a continuous random variable. So in this case, we have a continuous, some sort of a random variable. It's basically showing you the probability density function as a function of this. It can be useful to visualize your data. In fact, if you just want to plot that, if you just want to plot KDE, let's not do distribution plot. Let's actually do, let's delete these two lines, okay? Let's do SNS, I think it's called KDE plot. Yeah, right there, okay? So it's KDE plot, and again, pretty much the same thing. What do you want to plot? Let's plot manual. Yeah, let's plot manual, and let's go ahead and plot this, okay? There you go. So this is nothing but what you see here, but it's not a distribution plot. It's just a KDE plot. And you can actually, to make it visually appealing, again, that's all. Do not underestimate the power of beauty in your images or in your plots, okay? Oh, sorry, I was doing in place. It's actually shading equals to true, okay? Or is it shade? Okay, I think it's shade. Let's go ahead and run this. There you go. It actually shaded. Now you can, this is our KDE plot, and you can actually do multiple plots, right? So what happens if I just take this again and instead of manual, what is it called? Auto th2 shade equals to true. Let's go ahead and plot all of them. Okay, auto threshold 3 is the other one that I have, and auto threshold 4 is the final one. And let's plot all of these into single plot, and there you go. Isn't that pretty? I mean, I could have increased the size of this, but let's not do that for now. Okay, so well, I'm carried away by looking at the data. So the green line, the green one, which seems to be auto threshold 3, seems to be the one that fits the manual line very well. So it looks like whatever setting we used for threshold in auto threshold 3 seems to be fitting the manual one. Again, as a scientist, you always, I mean, okay, you look at the beauty, but then you look at the data, and I got distracted for a second. Let's get back. Sorry about that. So that's the KDE plot. Okay, so what do I mean, I have notes here to make sure I keep focused. So what do we do next? Let's just do some scatter plots. Okay, so for scatter plots, it is again, let's keep the fill NA as is. So for scatter plots, it's SNS dot. There are multiple ways again to do this. One is joint plot right there. Okay. And then you need to say what your X is and what the Y is, because this is a scatter plot, right? So let's say our X is manual, okay? And I want to plot manual against my Y equals to against auto th underscore. Is that what I called it? Yeah, auto threshold 2. And if I plot this, it's going to yell at me. Yeah. Let me go ahead and do that. It's going to say could not interpret manual or something, because what do you mean by manual? What do you mean by auto threshold? We need to say what the data is. Data equals to df. Where is the data coming from? So that's what we need to mention here. So when I do that, I hope we should see a scatter plot right there. Okay. So it's showing us the auto threshold 2's distribution on the Y here. On the X, it's showing us the distribution of manual. Okay. So that's the scatter. And by the way, if you want to, instead of just the scatter, if you want to, what's the term I'm looking for? The KDE plot, you can actually do kind equals to KDE, okay? Kernel density estimation. So kind equals to KDE, obviously you need to put that in quotes. So what type of plot are you trying to plot here? So when I go ahead and run this, now I think it should show a contour plot right there. And here you have the KDE of the manual. Here you have the KDE of auto threshold. Okay, so this is again when you are trying to, you have two variables. Now, what do I want to show next? Okay, let's do some pair plotting. Again, since we are talking about two variables, let's just do, instead of joint plot, let's actually do pair plot, where my data equals to df, or I guess you can just say df right there, so you don't have to do any of this. Okay, and let me see what else. So our data is df, and our x, let's go ahead. I'm actually cheating here by looking at the documentation of pair plot. How do we actually define pair plots? So it's nothing but we need to do x variables. So what do we want to plot? So basically the aim right now I'm going for is instead of one scatter plot, I want to say, okay, I want to compare my auto threshold 2, 3, and 4 against manual. That's it. So I want to keep like one constant manual, but then I want to plot these three, right? That's exactly what I'm going for. And pair plot is a great one for that. And let's say x variables equal to, what is it? Auto underscore th underscore 2. And let's copy this because I'm lazy. And the next one is 3, and the next one is 4. Okay, so these are my x's, and then we need to do y underscore variables, and let's just do manual, right? So that's what So let me go ahead and do a sanity check here. Let me move this a little bit. Okay, pair plot, and we know where the data is coming from. X variables is auto threshold 2, 3, and 4, and Y is that. Let's plot it. Okay, so there you go. The size is too small. If you want, you can add size equals to, I don't know, let's make it like 6 inches, for example, and then let's go ahead and plot. There you go. It's big, and I can expand this so you can see that's much nice, very nice plot. Size equals to 6, and you can also define the aspect ratio if you want, you know, which is nothing but aspect equals to whatever, you know, 0.6 or 0, whatever aspect ratio you want. So this is pair plots. It's only 15 minutes, so let me cover a couple more, and then I'll let you explore a few other plots here. So okay, so scatter plots. This is very important with linear regression, right? So we often look at okay, we have a scatter plot here, but can I fit it to a linear regression? So there is one thing I absolutely love about Seaborn, another thing I absolutely hate, which I'm going to show you both. So let me show you what I love about this, which is, let's see what data. Yeah, let's use the same thing. So it's called sns.lmplot. Okay, so lmplot gives us a scatter plot by overlaying a linear regression on top of it. So again, so what is my X data? Yeah, so we need to give X, Y, where the data is coming from. I'll talk about hue in a minute. Okay, so X is nothing but our manual, right? So we have been doing X as manual, and then our Y is equal to, let's say, auto threshold 2. Okay, that's our Y. What else? What else do you want to do? Data. I forgot about data. My data equals to df. Okay, and let's just plot this for now. Let's plot it and see what we get. Okay, so there you go. So this is, in fact, you can, yeah, let's see. Okay, so now hopefully you can see this. So this is all our data where we have plotted manual versus auto threshold 2, and it actually by default did fit a linear plot right there. This is something I absolutely love. Now coming to what I hate about Seaborn, there is no freaking way you can get the equation for that line. What is the slope and what is the intercept? I hope it's not my lack of knowledge in this case, or maybe I hope it is my lack of knowledge. But if any of you guys know how to display an equation along with this line, please let me know. But I'll show you another way of actually getting that equation, whether whether you display or not, in a second. But let me cover, because I mentioned hate, I hate to end anything with hate. So let me tell you a couple more things I love about this, okay? So now that we have data equals to, df, I can actually do order equals to 1, which is nothing but a linear regression, right? So when I do that, I should see exactly the same thing. If you want a quadratic, order equals to 2, then it would be a quadratic fit, which is pretty good, and you got the point, right? So this is the order. Now the cool stuff is I can actually add a hue, and hue is equal to I just thought about one thing. Let's actually print our data frame head. I just want to check one thing, what the column name is for set. So the column name is still defined as unnamed 0. I do not like that. Let's actually fix the column name. The reason I'm trying to do this is I want to do a linear fit and display the data for each set separately, not for the whole thing. Okay, so for that I'm actually changing the name of my column from unnamed 0 to, I don't know, let's call it image set or something. So the way we do that is df equals to df.rename, yeah, and columns equal to what? Columns equals to, what is my unnamed 0, unnamed 0, right? That's the column name, yeah. And then to what I want to change it. So I want to change that to image underscore set. And I hope that does the trick. Let us print this one more time. There you go. The column name is changed to image set. Again, this is a slight detour that I didn't intend to take, but it's a good one. So now let's go ahead and hue equals to, meaning in a way, think of hue as how do you want to separate this? How do you want to color this by? Yeah. Previously we did by, you know, in pandas, but here it's hue. Hue equals to what? I'm going to call my hue image underscore set. So it looks at image underscore set. It looks, it says that, okay, you have set 1, set 2, set 3, and set 4. So I'm going to color your plot into these 4. Okay. So there you go. Again, so set 1 in blue, set 2 in orange, in green, set 3, and set 4 in, I guess, that dark reddish or deep red, almost getting into brown color over there. So for each of this, it generated a separate line. Again, it's a shame that it cannot display the equation right away. Okay, so let us now, oh yeah, I promised to show how to display the equation. Let's go ahead and do that. Not display, but how to extract the slope and intercept if it is a linear. We know that, I think I've done this exercise in one of the previous tutorials, but it's worth repeating. So within stats, S-T-A-T-S, within stats, there is a function called linear regress, L-I-N, lin regress, that actually gives you the slope, intercept, the R value, R squared, well, R value, P value, and all of that. So that's pretty much it. I'm going to use that to extract those, and just to show you how to extract that, I'm going to just say unwrap slope, intercept. What else? I think the next one is R value. The next one is P value. Did I get it right? Yeah. The next one is P value, and then it also reports standard error equals to what did I call it? Stats. Stats, stats dot LIN REGRESS, lin regress, right? So linear regression of what? Of X and Y, right? So what is my X in this case? My X is nothing but the manual column, okay? And what is my Y? Which is auto DH 2. Did I get it right? Should stick with single quotes right there. That's pretty much it. So it actually calculates all of that, and now you can actually print all of these values. For example, print slope equals to, let's say, right, print slope equals to slope. So there you go. So hopefully we should see whatever that value is for slope. It's 0.772 something something. Okay, it actually prints slope, P, R, intercept, and everything. Okay, so this is it. So this is how you can actually extract. The complaint I was making earlier was, it would be nice if Seaborn actually, it has the numbers. It would be nice if it actually reported those numbers. That's pretty much it. Okay, what's the next thing I wanted to cover? Okay, if time's up, end here. That's what I have in my notes. But I would like to show you a couple more, at least one more. Okay, let's do one more of these. Let's erase everything. There's something called swarm plot. Like if you have different categories, let's say, actually, I think we have it, right? So manual versus auto. In the previous tutorial, we actually, there's the file. There it is. So in the previous tutorial, we actually defined a function where we looked at the manual values and then said everything that's below 100, call it a low. Everything that's above 100, call it a high count for cells. Let's use that to separate the data and then plot it independently in a swarm plot. Okay, so I'm going to do sns.swarm plot, swarm plot. And by the way, the file that we need to be reading is auto, what did I call, 2.csv. Okay, because that has the column that we need. Swarm plot, and again my x is what is my x? Equals to image underscore set, right? So image underscore set is nothing but, where is it? This one. Yeah. So that's my X image underscore set. And because it's already renamed there, we do not need this line. Okay. So image underscore set is my X, which is set 1, set 2, set 3. And Y equals to, I want to plot the manual values. Okay, that's my Y. And where is the data coming from? Data is equal to my data frame that I'm creating right there. And what else? Data, what else do we, oh yeah, the whole point of showing this is hue equals to, what did I call it? Hue equals to cell underscore count underscore index. Okay, cell count index, and that's my hue. Let's go ahead and plot it. There you go. Again, if you have the right type of data, this actually makes sense. So all we did is we are changing the color. We are adding the color based on the cell count index, whether it is low or high, and we are separating this as image sets for set 1, set 2, set 3, and set 4, and we are plotting the manual values, right? So the manual values right there. Again, I'm not sure if you find this as a great example, but hopefully it gives you an idea. Now, sometimes it makes sense to offset the two categories, so it instead of being continuous. So if you want to do that, I think it's dodge equals to true. If I plot this again, you'll see what I mean. So there you go. This is like a bit offset plotting. So there is so much control you have when it comes to Seaborn. That's exactly why I think you should know about it, and you should explore this, and you should continue using it. One good example, I actually have like a bunch of, I didn't plan on going through this, but I just want to show you. Let's see, I've written down something here. Let me go ahead and paste to show another plot that I'm working with. This is where, especially when it comes to machine learning, you have two things that you want to look at: cross correlation. Even in this example, you want to look at a cross correlation between two types of data. So in this case, all I'm trying to do is plot a heat map. And heat map of what? Heat map of of my columns right there, where I believe I said I just want integers. Yeah, my data, the correlation is all the data columns where the data type is int64, right? So the data type is int64 right there for auto threshold 2, 3, and 4. So I want to look at the correlation between auto threshold 2, 3, and 4. So it's dot CORR. So this correlates all int64 columns, okay? So once you do that, then it's just a matter of generating heat map where the input is my correlation, and then this is x ticks and y tick columns, and then the color map is exactly how do I want to color this. And again, you can experiment with this, and you can see all the diagonals, the value should be 1 because you're correlating the same value against the same thing here. Okay, so this is another way of doing your plots. Anyway, so this is almost a half-an-hour video, and I apologize for the length of it, but I hope you find this useful. And again, if you find this useful, please like this this video. And if you like the tutorials I'm covering, the series of these lectures I'm covering, please subscribe to this channel. It definitely encourages me. Thank you very much, and let us talk about a different topic in the next tutorial.